We're going to look at measuring angles today in radians. It's kind of like when you learned that the whole rest of the world uses the metric system and the United States uses feet and inches. This is a different unit of measurement for angles instead of degrees. It is used in math and science all the time. What an angle of 1 radian is if I take and I put my angle in the coordinate plane and I inscribe it inside a circle, and then if I wrap that radius around the outside, the size of the angle that's created is an angle of 1 radius. So like if I wrap that 1 radius around the outside of this circle, that's an angle of 1 radian. If I do it twice, that's an angle of 2 radians. 3 radiuses is 3 radians. Pi radians is actually 180 degrees straight line, which means a full circle 360 degrees is 2 pi radians. So if you're converting back and forth, 360 degrees is 2 pi radians, and you could divide that by 2, and 180 degrees is pi radians. If you don't write a unit of measure like a degree symbol on an angle, you assume that it's being measured in radians. So if you mean it to be in degrees, make sure you write your degrees symbol. So we're going to convert back and forth a little bit. So if you want to change 108 degrees to radians, you could multiply by pi over 180. If you kind of look at your units, you want your degrees to divide out, so degrees on top, degrees on bottom. And if you're typing in a calculator, just do 108 over 180, which gets you 3/5, and then you have times pi, so 3/5 pi or 3 pi over 5. If you're doing, again, negative 5 pi over 4, but we're going to degrees this time, I need to multiply by 180 over pi, which means pi divides out. And then if you multiply negative 5/4 times 180, it's negative 225 degrees. This one is one where your calculator may or may not give you an exact value. We like exact values when possible, so fractions instead of rounded off. So try 325.5 divided by 180. You probably have to use the division, not the fraction. And your calculator might give you 217 over 120 times pi. Or if it won't, change it to a fraction. You could do 5.68 with the pi multiplied in there. So if you're going to have to round it anyways, just multiply the pi times your value. This is negative 2.92 radians, so it's not like an exact multiple of pi. So it's, if you multiply things together here, we don't really want to leave a pi in the denominator, so just go ahead and divide it by pi and get negative 167.304. So if you want to evaluate a trig function of an angle measured in radians, since you're probably not that comfortable working with radians, I would go ahead and just convert back to degrees. So take that negative 5 pi over 6 radians and multiply it by 180 over pi, which is going to give you 150 degrees. So if you're doing cosine of 150 degrees, let's go ahead and draw it in the coordinate plane here. So it's negative, which means I'm going to rotate clockwise, and then think about making that a triangle and looking at your reference angle. So from negative 150 up to 180 would be a 30-degree reference angle. And then if you think about your 30, 60, 90 special triangle, opposite would be 1, it'd be negative, and you would be negative for both your x and y values, since we're in quadrant 3. This is cosine, so we've got adjacent over hypotenuse. So cosine of that negative 150 degrees would be negative square root 3 over 2. So it doesn't matter if your angles in radians or degrees, they've got the same trig function values. If I change cotangent of 3 pi over 4 into cotangent of an angle in degrees instead, it'd be equal to cotangent of 135 degrees. Again, draw yourself a little picture, think about your reference angle. So 135 would be in quadrant 2 for its terminal side, and then your reference angle down to the x-axis, down to 180, is an angle measure of 45 degrees. So we're looking at your 45, 45, 90 special triangle. And then we're doing cotangent, so we're going to have to do adjacent over opposite, which is negative 1 divided by positive 1. So cotangent of 3 pi over 4, or 135 degrees, is just going to be negative 1.